addition to Captain Chong, we also need other elements. For example, we need sodium and potassium. Sodium and potassium, they are important because in our nervous system, the nerve cell, we call that neurons. Neurons, they will generate an electrical signal. We call that action potential. Action potential is an electrical signal that our nervous system uses to communicate with other cell. And in order to generate this electrical signal action potential, our neuron must maintain a stable concentration of sodium and potassium inside and outside of the nerve cell. If the relative concentration of sodium and potassium is changed, then neuron cannot generate or fire action potential, then we can die because of that. And of course, calcium is important because they make out of our skeletal system, they make the bone. And then iron. Iron Man, yes, it is important because of the movie. Well, not really. Iron is important because of hemoglobin. So what is hemoglobin? Hemoglobin is a molecule consists of protein and Fe2+, meaning that it has an ion of iron ion. So the function of hemoglobin is to carry oxygen and carbon dioxide in your blood. Your red blood cell has hemoglobin, and then hemoglobin is the molecule that carries oxygen and carbon dioxide. And last but not least, we also need magnesium. At our level, you can assume that the function of magnesium is just to maintain the concentration of our blood or our body fluid in general. When you go to a higher advanced level, you know that in our brain, we have something called Nmda receptor. Nmda receptor is for learning and memory, specifically for spatial learning and memory. And the Nmda receptor uses magnesium ion to block the channel, to block this receptor. So magnesium can regulate the learning and memory of the spatial memory. So let's take a look at the atomic structure. Atom is the smallest part of the element that displays properties of the element. Okay. We have Dalton. John Dalton is the one that developed atomic theory. So because he's the one who developed atomic theory, he also developed the weight. The weight of the atom is called Dalton. Yeah, he used his last name to name the weight of the atom and subatomic particle. As I mentioned previously, subatomic particles. What are the subatomic particles? If you break down atom, then you get proton, neutron, and electron. So we call these three the subatomic particles. So proton, they are positively charged, which is important to know. How do you memorize it? P goes with P. So you have to memorize this. And then neutron is uncharged. Uncharged, you may call it neutral. So N, go with N. So you also have to memorize this. Last but not least, electron is negatively charged. Well, for that, you may assume that, oh, E goes with E. This is kind of arbitrary. But yeah, P, proton goes with positive P, and goes with neutral. For proton and neutron, you can find them in something called a nucleus. Oops, sorry, wrong spelling. So what is nucleus? Nucleus is the center part of an atom. And nucleus is also where most of the mass of the atom located. So proton and neutron contribute to the mass of the nucleus. Electron, on the other hand, they just they surround the nucleus. The relationship between nucleus and electron is like the Earth and the Moon. The Earth is like the nucleus, the Moon is like the electrons. Or you can also think about the Sun and the Earth. The Sun is the nucleus, the Earth is the electron. So electron move around the nucleus. So proton. Proton determines the types of the element. This is important. For example, when you have 27 proton, then you will have iron. When you have 79 proton in the nucleus, then you have gold. Here you don't see this. If you download the PowerPoint lecture slides, then you will see this. If you have 6, carbon 6, if you have 6 proton, then you will form carbon. So carbon has 6 proton. So the element depends on the number of proton in the atom. Okay, neutron, they are uncharged. They determine the physical stability. What does it mean, physical stability? First of all, we need to define isotope. So isotope, they are same element. Same element, meaning, what does it mean? It means that they have the same number of proton, but they have different neutron. What do you mean different neutron? They have different number of neutron. I should say they have different number of neutron. They have different number of neutron. For example, here, when we said carbon 12, what does it mean carbon 12? Carbon 12, it has 6 proton because it is carbon. When it is carbon, then it always has 6 proton. 12 meaning that it has 6 neutron. So 6 neutron plus 6 proton, then it is 12. What about this carbon 13? Carbon 13, well, by definition carbon, that means it has 6 proton. And then 13, that means it has 6 proton plus 7 neutron. 6 plus 7 is 13. Last one, you don't see this, I cover this up by my video. It is actually called carbon 14. Carbon 14, well, carbon, that means it has 6 proton. Then how many neutron? It should have 8 neutron. So these three, carbon 12, carbon 13, and carbon 14, we call them isotope. This is what we mean by isotope. They are the same element, but different number of neutron. Different number of neutron. So different number of neutron. So the carbon 12, carbon 13, carbon 14, they are isotopes to each other. Then what do we mean the number of neutron determine the physical stability? It turns out that carbon 12 and carbon 13, they are not radioactive. But carbon 14 is radioactive. So in other words, carbon 14 has 1 or 2 more neutron, and then it makes it radioactive. So it makes it less stable than carbon 12 and carbon 13. So this is what we mean. The number of neutrons determine the atom's physical stability.